We have this function f of x equal to x square minus 1 times absolute value of x square minus 3x plus 2 plus cos of again absolute value of x. This function is not differentiable. Right? So for a function for it to be not differentiable, either it should not be continuous, either continuity might be breaking, or there are some sharp edges like this, sharp edges or sharp spikes or some breaks like this. Okay. So this function, there is an absolute value of x. Cos of absolute value of x is cos x only. Right? Because cos of minus x is also cos x. Cos of plus x is equal to cos of minus x. So absolute value doesn't do anything to cos x. So this is fine. But we have x square minus 3x plus 2, which is nothing but x square minus 2x minus x plus 2, which is nothing but x minus 1 into x minus 2. Right, this we can write it as x into x minus 2 minus 1 into x minus 2. So we have two roots here. Basically, when x is greater than 2 or greater than or equal to 2, or when x is less than or equal to 1, this is positive. Right, so this we can write it as x square minus 1 times x square minus 3x plus 2 as long as x is greater than or equal to 2 or x less than or equal to 1. Otherwise, if it is lying between 1 and 2, this becomes minus of this one, right? Absolute value of this thing, because this expression is negative, right? If x is lying between 1 and 2, this expression is negative, so we'll write it as minus of x square minus 1 times x square minus 3x plus 2, right? So this is also a polynomial, this is also a polynomial, right? So x square into x square, x square into x square, whatever. So this is a polynomial. So p of x plus cos x something. Here some q of x plus cos x. This is also polynomial. This is also a polynomial. And what we have to take care here, and because this is sum of two polynomial and a continuous function, so these two are definitely continuous, because this is continuous, this is continuous, this is continuous, this is continuous. There is no denominator zero case here. So both the cases are continuous. So we are not worried about continuous. We are worried about the sharp edges right now. Right. Continuous is anyway sorted. We are worried about sharp edges. Why? Because x greater than or equal to 2, this is the equation. And when x less than 2, this is the equation. This is a polynomial. Right. Forget about cos x. Right. Cos x plus a polynomial would be smooth as long as the polynomials are smooth. Right. Either x greater than or equal to 2, we have cos x plus px plus p, and x less than 2, we have cos x plus q, right? As long as this cos x plus p is anyway continuous, cos x plus q is anyway continuous. But what we have to ensure? We have to ensure that the slope of this function and this function at x equal to 2 is actually same. Right, slope of this function and this function. So cos x is anyway common. If we are ensuring that slope of p and q at x equal to 2 is same, then we can say that this function is differentiable. Right, it cannot happen that when x less than 2, when you are approaching this function from the left side of 2 and right side of the 2, you are getting two different slopes. If you are approaching from the left side, you are getting one slope, and if you are approaching from the right side, you are getting another slope. Then this function is not differentiable. It is continuous definitely, but still we have, for differentiability, we have to get the same slope. Right, now this is a polynomial, x square. This product is a polynomial. Let's take this first case. When you're approaching from the right side, this is a polynomial, x square into x square, x power 4 something plus something. Right, now when x is greater than 2, obviously this is positive. Right, this polynomial, if this point is 2, this is positive, and x is 2 is a root, so that means before 2, this polynomial looks something like this. We're taking a very small interval before and after 2. Right, before 2, this one is negative, right, slightly before 2. So that's why p of x P of x is positive after 2, 2 plus it is positive, and 2 minus it is negative. Right. It is like this. P of x, whatever this function, it looks something like this. Just slightly before and after 2, it looks like this. Now, this function q of x is exactly minus of this thing. Right. When x less than 2, again a small interval when x less than 2, q of x is exactly minus of p of x. That means when x less than 2, this part, whatever this part, will get inverted here. Right. Earlier, which was smooth, suddenly it has become a sharp edge here. Right. Because this is x less than 2. We are not even worried about what is happening at minus 10, minus 20 and all. Just after 2 and just before 2. And if this was the function p of x, we realize it looks something like this. After 2 it is positive, before 2 it is negative, because 2 is the root of x square minus 3x plus 2. We are not worried about other roots and all, just before 2 and just after 2. Now, but p of x is not the overall function, right? Overall function is p of x plus cos x when x greater than or equal to 2, but when x is less than 2, it should be q of x, and q of x is nothing but minus of p of x. That means that is this function. So basically our function is looking something like this. This bottom one is exactly flipped to the top. When x is less than 2, whatever this part is there, right? It is just flipped. Obviously, when the flipping is happening, what does that mean? If you approach from the right hand side, this is the slope. If you are approaching from the left hand side, this is the slope. There is no way both slopes are matching, right? Both slopes will match when minus m is equal to plus m, which is nothing but slopes are 0. When slopes are 0, then this kind of flipping will work. But here, when you have just flipped, right, this the slope, whatever is there, we have just flipped it. So there is no way the slopes will match, right? So that means at x equal to 2, there is actually a break in the slope, or there is actually something like this, some corner. Slopes are different from the both the sides. So clearly it is not differentiable at 2, right? So that's what we have done here. X square minus 3x plus 1, this is actually product of this two, and it is positive when x greater than 2 or x less than 1. You can say, and it is negative on x is lying between 1 and 2. So when x is equal to 1 or 2, it is actually 0. So whether you put it in negative or positive, put less than or equal to, greater than equal to, doesn't matter much. Cos of absolute value of x is always cos x, because cos of minus x is cos x. Right. Now this is what we have discussed. This is p of x. This is q of x. Or this is q of x. And this is p of x. Right. And p of x, q of x is actually negative of p of x. That means there is a flip. There is a flip here at 2. This point is 2. So that's why slopes are not matching. It is not differentiable at 2. Right, guys? Simple problem, but we need little bit of conceptual understanding about absolute function and differentiability criteria. Right, guys? Thank you.